Okay, in this question, we are given that the weight of the apples is normally distributed. Okay, it is normally distributed with mean as 120 gram and standard deviation as 24 grams. The apple lesser than 90 gram are small and weighing more than 140 gram are graded as large. The remainder are the medium. So what we have to do, we have to prove that the medium graded area or the probability of getting medium graded is 0.692. So how we are going to attempt this question? As we know that the area of normalized distribution is 1. So we can find the area for the small plus area of large plus area for medium. That would be equal to 1. So what we have to do in this question, our attempting criteria would be, we have to find this area, because we can find this area, we can find this area, and then subtract it from 1, we will get the remainder area, that is the area for the medium one. So let's get started. So first we need to convert our x variable or normalized variable to standard normalized variable. So for conversion, we are going to use the formula z is equals to x minus mu upon sigma. That would be, for the smaller, that would be 90 minus 120 upon 24. That would be minus 30 by 24. That's equal to, let's calculate, 30 upon 24. That is 1.25. So this is minus 1.25. So for the large, we are going to perform the same calculation. Z is equals to, for the large we are given 140 minus 120 upon 24. That would be 20 upon 24. That would be 0.8333. Let me confirm it. 20 upon 24, yeah, 0.863. So now what we have to do, let me draw the diagram first so that it would be easier for you to understand. So this is the normalized distribution curve. This is our mean value. This is the region for the large, and this is the region for the small. So any number lesser than small would be that area, and any number greater than large would be that area. We need to find the middle area. I would highlight it with the red. We need to find this area. So for calculating for solving this question, what we are going to do, we are going to find the phi of 0.25, phi of, so we are going to find the phi of minus 1.25 and phi of 0.8333. So for calculating phi of 1.25, what we are going to do, phi of minus 1.25 would be equal to 1 minus phi of 1.25. So for phi of 1.25, let us go to the formula sheet. This is the formula sheet. Phi of 1.25. This is 1.2. Okay, let me highlight it. 1.2, 1.2, and 1.25. This would be our area, 8.944. Next digit is 0, so we need not to get 0.8944. So this would become 1 minus 0.8944. That would be equal to 1 minus 0.8944. 1056. So this would be equal to 0.1056. So the next thing is finding the phi of z greater than 0.833. This would be nothing but 1 minus finding the phi of z lesser than 0.833. Let me erase it. So to calculate the phi of 0.833, again we have to go to our data sheet. 0.83 are these numbers. Okay, 0.83 is these three numbers and this number. So this would be 0.7967 plus 8. One minus 0.7967 plus 0.0008. So that will become 0.7967 plus 0.0008. 7975. Okay. 0.7975. This is equals to 1 minus 0.7975. That will become minus 0.202. See, 0.2025. So what we have to do, we have to know we got this as an answer and this as an answer. Okay, what we have to do, we have to subtract these two numbers from the from 1, since our total area is in the normalized distribution is 1. So phi of, okay, or let me put in properly, probability this way, probability is equals to 1 minus 0.2025 plus 0.1056. 2025 plus 1056, 308. That would be 1 minus 0.3081. That would be 6919. 0.699. That's it. Okay, in this question we have asked that 4 apples are chosen at random. What is the probability that at least 2 are graded as medium? No, we can change our normal. We have learned from our previous lessons that normalized distribution can be changed to binomial distribution if n into p is lesser than 5 and npq is also lesser than 5. So let's check it first. Since n is 4 times p is 0.694 because our required region is the medium one. So 694, it's not 694, it's rather 6919, I think so, 6919. So okay, let me get it. So 4 into 0.6919. Let us check it first. 4 into 0.6919. That is 2.76, which is lesser than 5. So 2.7 something, which is lesser than 5. So we can assume a binomial distribution. So the next thing is we are asked at least 2 apples are medium graded. So at least 2 means either 2 or it can be 3 or it can be 4. So we can have either 2 at least 2 medium sized apple, or we can have 3 medium sized apple, or we can have 4 medium sized apple. So we are going to find the probability of these things. To calculate these, we are going to use the formula 4C2 into probability of success is 0.6919 raised to the power of 2 into 1 minus 0.6919 raised to the power 2 plus 4C3 into 0.6919 raised to the power of 3 into 1 minus 0.6919 raised to the power of 1, which would be added in again and plus this plus should be over here. We rub it again. Okay, the next thing is 4C4 0.6919 raised to the power of 4 into 1 minus 0.6919 raised to the power of 4 minus 4 is 0. So this is how you are going to attempt this question. After solving, you are going to get the particular result. Got it? Okay, in this question, we have been given that the light bulbs are normally distributed with mean of 2000 and standard deviation is sigma. The probability that the life is more than 1800 is 0.96. We need to find the value of sigma. So if we draw the normalized distribution curve first, assume that this curve is okay. Okay, this is our mean, this is around 2000, and he's saying that 1800, greater than 1800, so this would be obviously 1800, and this region beyond 1800 is, this whole region is, have the area of 0.96. What we have to do, we have to find the value of sigma. No, the data is given, this is given that it is normally distributed. First we have to standardize this first. So this would be Z is equals to 1800 minus 2000 upon sigma. What that thing? So phi of Z, we have given that phi of Z is equal to 0.96. First we have to calculate the area. Oh, sorry, we are provided with the area. We need to calculate the value of Z from our table. Okay, this is our table. We need to find the value of 0.96. 0.95991, and this is the 0.955 plus 1, that would become 0.9600. So this is at, this is at 1.7 plus 1. 1.751, that would become 1.751. So Z became what we so Z became 1.751. So now we just have to simplify it. Phi of 1800 minus 2000 upon sigma is 1.751. We are going to solve it. So this is the area. When we crossed it, it became minus 1.5751. This would be 200 upon sigma is equal to 1.751. No, we would divide this. (200) divided by 1.751. That is 114.22. So this would become, sigma would become sigma would become 114.22. Okay. In the next part, we have been asked that they have introduced a new technology, and on the basis of new technology, our the average out of average 1 out of 5 new bulb has the life of more than 2500. So what is the question? They have 300 new bulbs. They have 300 new bulbs, and we need to use approximate distribution to find the probability that lesser than 70 have the life of more than 2500. Okay. Now, first we need to find the probability of success. The probability of success is 1 out of 5, so it would be 1 by 5 is equal to 0.2. The probability of failure would be 0.8. So, first we need to approximate it. I'm going to approximate this binomial to normalized distribution. But this would be if P into N into P, that is 300 into 0.2 is greater than or equal to 5. So then that would work. If let's see, if this would be 60, which is greater than 5, so our normalized distribution would work. And also we have to check it with NPQ as well. 60 multiplied by 0.8, that would become 48. So again greater than 5. So our this criteria is okay. No, we have normally distributed data with 60 as the mean and 48 square root as the sigma. Now we need to find the probability of x is lesser than 70. First we need to convert it into normalized distribution. That would be z is equals to 70 minus mu was 60 upon sigma. Sigma is under root 48. That would be 10 upon the square root of 48. Let's take the square root of 48 as well. 48 and that is square root 6.928. This would be 6.928 and 10 divided by 10. We would use this equal. Okay, let me do it again. 10 divided by 6.928. This is 1.443. So this is 1.443. Now we have to find the phi of x is lesser than 1.443. So we need to go to the normalized distribution chart again. Now to calculate the value of phi of 1.3712, we again have to refer to our formula sheet. This is our formula sheet. Okay, and 1.371. So this is 1.3. This one is 1.3, and we have to go to that thing. So this is again 1.37. Okay, I do it first, and 1.37 and then 1. So that would be 0.9149. So the answer would be phi of 1.3712 is 9149. Okay, in this question we have to justify our approximation. Even though I have justified it in the previous part, but for justifying it, we just need to show that NP should be greater than 5. So N, since N was 300 and P was 1 upon 5, that is 60, which is greater than 5, and also NQ should be greater than 5. So 300 into 4 by 5, that would be 240, something like that. In some other books, they do NPQ as well. This should again be greater than 5. I recommend that thing. 300 into 1 over 4 into 4 upon 5. So just insert and we will get our required answer. 1 upon 5 was this. So this is 1 upon 5. Sorry for that. This would be, I think so, 48. So this is again greater than 5. This is again greater than 5. So this is our required answer. Okay, in this question, they have provided a set of data and they want us to make the stem and leaf diagram for that number. So we have to make the stem and leaf diagram. And they have added some limitation that the anvil should be on left hand side and the rectangles should be on the right hand side. Before working, we need to have some defined key for ourselves. So this, let us design this thing. Okay, the key would be 17-3 means 173. On right, sorry, let me do it again. And 16-6 means 166 on left. Okay, since we are given that anvil should be on right side, we compute our table first. Say we work with 15, 16, 17, 18 and 19 as well. Okay. Let me some numbers first. Okay. Now 15 for the anvils. So there is only anvil was on the left side, so this would be 158. And let us go for 16 as well. 16 is 165, 116 only two entities. So first 5, then 9. In 17 we are given with 173, 175, 170, 172. So it will be 0, 2, 3, 5. In say 18 we are given with 180, 181, 184. So it would be 0, 1, 4, 0, 1, 4. And in 19 there is only one entity, that is 196. Let us count it first again. So we, in bracket it is better to write the number of entities. One plus 2, 3, 3 plus 4, 7, 7 plus 3, 10, 10 plus 1, 11. So again we are going to do the same work for the rectangles. There is no entity in 15, so there is only one entity, 166. Nothing else, so that would be 6. 70, 170, 1, 2, 2, 8. 0, 1, 2, 2, 8. In 80 that is 1, 2, 3, 3. 1, 2, 3, 3. And here it is 2. Let us write it again, the number of entities over here. So these are 1, these are 1, 2, 3, 5, these are 4, this is again 1, that is 1 plus 4, 5, 5, 10 and 10 plus 1, 11. So this is your required diagram. Okay, in this part we are asked to find the interquartile range. We are required to find the interquartile range and the median of anvil. So when we go back to our data, the anvil was at left hand side. So when we go for the median is 1, 2, 3, 4, 5. This is our 5th time. This is 6th time. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. So the median would be that term, 3. Just you have to count it, count the boxes, and just write median is equals to 3. No, for interquartile range. We need to find the middle of these 5 terms. Since these are again 5 terms, the middle would be 9. And for that, the middle is 1, 2, 3. Okay. So, okay, I did make a mistake over here. The median would not be 3, rather it would be 173. At time, these are the blundering mistakes. You need to have it 1, 7, 1, 7. And for upper quartile, the answer was something 1, that is 181. 181. For lower quartile, answer was 160. Interquartile range is equals to upper quartile minus lower quartile. That will be 181 minus 169. And again, I will calculate 181 minus 169 is equals to 2. Okay, in this question, we are asked that 11 groups of the L1 are denoted with the height of 11 groups we are given with these data. Their summation x and summation x squared. 3 new members are added. We need to find the standard deviation of the total 14 members. First, we need to find the summation x. Summation x would be 1923 plus the new entities 166 plus 172 plus 182. That would be 1923 plus 166 plus 172 plus 82. That is 2443. Equals to 2443. Now we need to find again the summation x square as well. Since we know the sum of the previous ages square, now we have to add the new number square so that we would get the total square. That would be 166 166 square 27556. That is 27556 plus 182 squared. 182 squared. 172 squared. 29584. 29584. That is 337 all these numbers are together. This is 337,221 plus 27556 plus 33124 plus 29584. That is 427485. 427485. Now we need to find the mean of standard deviation of the 14 group. For standard deviation, we need to get the formula first. The formula for standard deviation is this number, summation x squared upon n minus x bar squared. Or there is another formula. See in the data sheet as well. It has to be that formula. Okay, I don't know if you can see that, but the other formula was summation x squared upon n minus summation x upon n whole square. This would also help you to find standard deviation. So that would become 427,485 upon 14 minus summation x squared was 2443. 2443 upon 14 whole square. Next we are going to find with the calculations. So if you go to your calculator, this will be 427,485.50. This is 30534.6. 30534. That is 30534.6. 4264 minus 2443 upon 14. 2443 answer that square 30450.25. 30450.45, and we got to get the annual test. So if you calculate it, that would be 30534.64 minus 30450.45, and we need to get the square root of it, 9.17. So the standard deviation for the next 9.17